Okay, hello friends. Today I'm going to discuss Hungarian method for solving assignment problem, right? So Hungarian method is a method which is used to solve assignment problems, right? So now what is in this method? Let me explain you. What is assignment? Assignment means when you are assigning some particular job to some particular machine or some particular person so that you can complete that job in a minimum time at minimum cost. What we are doing, we are minimizing something in assignment. So an assignment is by default minimization technique. It is as similar as transportation. As transportation is a minimization technique, similarly assignment is also a minimization technique. Second important thing, that assignment is a part of transportation. It is just an extension of transportation. So this is a question which we need to solve through Hungarian method. So let's see what is there. So okay, so in this question, what we have to do, we have to minimize job completion time. So job completion time is given in this question, right? So we have to minimize that job completion time. So what are the steps for doing this kind of assignment problem? The first step is row reduction. Second step is column reduction. Third is assignment, and the fourth is uh, if solution is not optimal at step 3, then we will revise our table. So a table means that matrix. So how we will do row reduction, that I am going to talk about, right? So what is the lowest number in this particular row? 5. So I will subtract the entire row from this particular lowest number. So 10 minus 5, that is 5. 5 minus 5, that is 0. Then 9 minus 5, that is 4. Then 18 minus 5, that is 13. Then 11 minus 5, that is 6. Similarly for P2, second row, what is the lowest number? 6. So 13 minus 6, that is a 7, right? So 19 minus 6, that is a 13. And after that, it becomes 0. 6 minus 6, 0. 12 minus 6, 6. 14 minus 6, 8. Similarly, what is the lowest number in row third? That is a 2. See, in this row third, that is 2. So 3 minus 2, that is 1. So 3 minus 2, 1. 2 minus 2, 0. 4 minus 2, 2. 4 minus 2, 2. And 5 minus 2, that is 3. Now, what is the lowest number in row 4? That is P4. What is the lowest number? Lowest number is 12. Sorry, 9. Lowest number is 9. So that becomes 18 minus 9. So 18 minus 9, it becomes 9. So 18 minus 9, it becomes 9. So this is 9, this is 0, this is 3, this is 8, this is 6. Now P5, what is the lowest number? 6. In this particular row, lowest number is 6. So 11 minus 6, so it becomes 5. It becomes 0. It becomes 8. It becomes 13. So how 13? 19 minus 6. So it becomes 13. And 10 minus 6, it becomes 4. So now we have done this row reduction. That is step 1 is now completed. Now come to column reduction. The same thing I have to do with column wise as well. So what is the lowest number in this particular column? What is the lowest number? Let me check. What is the lowest number? Lowest number is 1. So 5 minus 1, that becomes 4. 7 minus 1, that becomes 6. 1 minus 1, that becomes 0. 9 minus 1, that becomes 8. 5 minus 1, that becomes 4. and it is a 0, so we need not to do anything, because if lowest number is 0, then the column will contain same value, right? I hope you are clear. uh, 0, 13, 0. So we need to only copy the values. That's all. Now again here we are getting lowest value as a 0. So we need not to do anything. We just need to copy 4, 0, 2, 3, and 8. But here we don't have any 0. So lowest number is 2, and I am going to solve it. So 13 minus 2, that becomes 11. 6 minus 2, that becomes 4. 2 minus 2, that becomes 0. 8 minus 2, that becomes 6. 13 minus 2, that again becomes 11. Now here again, lowest number is 3. So 6 minus 3, 3. 8 minus 3, 5. 3 minus 3, 0. 6 minus 3, 3. 4 minus 3, 1. So this is something, this is the table now we have, where we can do some assignment, right? So this is the table where we can do some assignment. So how to assign? So one thing we need to always recall, or we need to remember, that we assign anything, or we do assignment only after column reduction, not after row reduction. So after row reduction, we have to do second step, that is column reduction. Now third step, that is our assignment. So we will do assignment on the value on the table which we obtained after column reduction. Okay. So we are doing assignment here. So column reduction. So that is our step 3. So step 3 I am doing in this particular column reduction table, right? Okay. So let me finish this here. Okay. So what is our first row? So our first row is, so our first row is P1. And in this P1, is there any single 0? Yes, there is a single 0. So I have to assign only when there is any single 0 in any particular row or particular column. So we start assignment row wise. We start assignment row wise. Then column wise. So don't start assignment from column wise first. Start assignment row wise first. So this is 0. So once I have allotted any value and assigned any 0 in any row, so I will cut that column. So always recall, when we are assigning in row, we are cutting columns. And when we are assigning any value in column, we are cutting rows. Okay. So this is something which I have to mention it here. Okay. Now in the second row, is there any single 0? Yes, this is a single 0. So I have to cut this column. In the third row, P3, is there any single 0? No, there are 3 zeros. This 0 and these two zeros are also there. Now in fourth row, is there any single 0? No, there was only 1 0, and that is already cut. Now in fifth row, there is any single 0? No, there was only 1 0, and that is already cut. Now come to column wise. In job 1, is there any single 0? Yes, this is a single 0. And when we are assigning any 0 in columns, then what we are cutting? We are cutting row. Right? So we are cutting row. Now come to this job 2 column, it is already deleted. Job 3 column, it is already deleted. Is there any? Now come to job 4. Is there any single 0 in job 4? No. So skip. Is there any single 0 in job 5? No, there is no single 0. So how many assignments we have? We have only 3 assignments. Okay. So let me check whether this solution is optimal or not. Okay. So what is the condition of optimality? So optimality condition says that number of assignments should be, so I am writing it here. optimality condition. So optimality condition says that number of assignments equals to number of rows. So this is our optimality condition, which we need to recall all the time. So number of assignments should be equal to always number of row, right? Number of rows. So in other words, we can say number of lines. So how many lines are here? 3 assignments means 3 lines. See, there are 2 vertical lines and there is a third horizontal line. So number of lines are also 3. Number of assignments are also 3. So whatever the term you want to use, you can use. So number of assignments means we have 3 zeros which are assigned. P3 is assigned to job 1, P2 is assigned to job 3, P1 is assigned to job 2. So these are the 3 assignments. So optimality condition is not reached. Not reached. What happened? Why it is not reached? Because number of assignments are 3 and number of rows are 1, 2, 3, 4, 5. So 3 is not equal to 5. So it is not optimal. It is not optimal. So what we have to do then for getting this solution optimal? So here we are observing 3 types of values. 3 types of values. Okay, so 3 types of values. So some values are uncovered. So which values are uncovered? Let me check. Some values are uncovered. Which one uncovered? This 11, 3, 4, 5, 6, 3, 1, 11, and this 8, and this 4, and this 4, and this 6. So these values which are marked through green color, these are uncovered values. Apart from these uncovered values, there are some values which are covered and there are some values which are at intersection. So which are at intersection? This 0 is intersection, at intersection. This 2 is again at intersection. Fine. So this is at intersection, and rest of the values, let's say for example this, let's say this 0 or this 0 or this 0 or this 4 or this 0, these are the values which are covered but not at intersection. So technically there are 3 types of values. So let me see what is this. There are technically 3 types of values. So what is that value? The first one is uncovered values. First one is uncovered values. Second one is values which are covered, and third one is the values which are covered also and at the intersection, lying at the intersection. So the values which are covered, there I have not to make any change. There I have not to make any change. So the value which are uncovered, there I will subtract a smallest value of smallest uncovered value. Smallest uncovered value. Smallest uncovered value. So which type of value we will subtract? Smallest uncovered value. Right? Now what we will add? Where I will add at intersection, and where I will subtract, that is in case of uncovered. So where I am going to minus the value in case of uncovered values, and where I am going to plus the value in case of intersection value, and where I am not going to make any change, that is the case of covered values. Right? So I have shown you which are the uncovered values. The uncovered values which are not cut by any line. Covered values which are cut by any line. And intersection value which are falling on the point where 2 lines are intersecting each other. Right? So let me erase this so that you can get some clear idea. Right? Okay. So let me write it again. This value which by mistaken deleted. So this value is 3 and this value is 1, right? So let me write these values here again so that you can understand what exactly I am doing, right, with this, right? Okay, so I am revising this solution. So what is my smallest value? This one. This one is my smallest uncovered value. Again, I am repeating, this one is my smallest uncovered value. What I have to do? This I have to subtract, 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 right. Similarly, in all uncovered values. Here again in 8 and this 4. Now what I have to do with the intersection value? So this one, this is smallest uncovered value, I will add on intersection. This is smallest uncovered value. So where is this intersection? Here. So here I will add plus 4. And he, sorry, not 4, 1. Not 4, 1. 1. Right? So where I am adding this? On this green circled value. So again, 2 is again, that green circled value is at intersection. So here again I am adding 1. So I am going to make fresh table here. Right? I am going to make fresh table here. Okay. Okay, so let me write like this way. So this is my revision table. 1, 2, let me see what is this. So this is my revision table, revised table. This is my revised table. What I have done? I have subtracted, I have subtracted or reduced, or I have reduced this one smallest value from this uncovered value. So that is 4 minus 1, that is 3, 6 minus 1, 5. So I am writing it here. 4 minus 1, 3. Okay. Let me go to down. Okay. So then it will be more clear picture, right? There will be more clear picture if we keep it here. You can see it parallelly what is happening, right? Okay. Okay, now see. So what I have done, I have subtract smallest value from smallest uncovered value. Smallest uncovered value, which is the smallest uncovered value in our case, that is this 1. This is 1. That I have subtract from uncovered value. So which are uncovered value? 4, 6, 8, 4, 11, 4, 6, 11, 3, 5, 3, 1, right? So first I am subtracting or reducing, right? So 4 minus 1, 3. And 6 minus 1, 5. And 8 minus 1, 7. 4 minus 1, 3. And here come again 11 minus 1, 10. Here 3. And 6 minus 1, that 5. And then this is 10. This is 3 minus 1, 2. And 5 minus 1, 4. And 3 minus 1, 2. 1 minus 1, 0. Now check it. So see this. 4 minus 1, it becomes 3. 6 minus 1, it becomes 5. So similarly, I have done for all the uncovered cells, right? Okay. I hope it is clear. Now I am going to values which are lying on intersection, right? Which are lying on intersection. So which are those values? The 0 and 2, which are green circled, right? The 0, this is lying on intersection, right? The 0 and 2. So 0 is lying on intersection. So I am adding this smallest value. I am adding this smallest value on intersection value. So 0 plus 1. So it becomes 1. and 2 plus 1, it becomes 3. And no change in remaining covered values. So as it is, I am going to copy. As it is, I am going to copy 0, 0, 0. Right? So as it is, I am going to copy. So let me use some different colors so that you can easily discriminate. Okay. Let me use some different color. Yeah, this color. So I am copying it. Okay, fine. So it is 0. Oh no, this color is not good. So I will use some different color. I will use this red. Okay, fine. 0. This is covered, but not at intersection. 0. And this 0. This is 3. This is 0, 0. And here it is again 4. It is 0. It is 3. And it is 8. I'm not wrong. So it is 3 and 8. And similarly, this is 0 and this is 0. So red color values are those values which are covered but not at intersection. You just check it once again. Let me use this different color. See, this is covered but not at intersection. So as it is written, right? You can see here, this is covered but not at intersection. So as it is written. Okay, fine. So now again I will do assignment. Again I will do assignment. Right? Okay, fine. So let's do assignment. So in the first row, that is P1, is there any single 0? Yes, there is a single 0. Assign that 0 and cut that column. In second row, is there any single 0? Yes, there is a single 0. Assign that 0 and cut that column. In the third row, is there any single 0? No, there are 3 zeros. 1, and this is the first 0, and this is the second 0. This is the third 0. First 0, second 0, and third 0. Right? So there is no need of doing assignment. So skip. Right? Skip. Skip. Now come to the fourth row. Is there any single 0? No, there was 1 0, but it is now cut. In the fifth row, there is any single 0? Yes. There were 2 zeros, but earlier, now 1 0 is cut. So I will assign the second one. Now second one is single 0, right? Because the other 0 is already cut. So this is the single 0. So now it is cut. Now go to column wise. So column wise, there is any single 0 in this column? Job 1, yes. Assign that and cut row. So again, I am repeating, when I am cutting, when I am assigning in rows, I am cutting columns. And when I am assigning in columns, we are cutting rows. Okay. So there should not be any confusion for this. Okay. Now, job 2, column is already deleted. So no need to do anything. Job 3, column is deleted. Now come to job 4. Is there any single 0? No. There was only 1 0 and that is already cut. In job 5, it is already deleted. So no need to do anything. So same process. Again, find smallest uncovered value. Smallest uncovered value. So smallest uncovered value. Which is the smallest uncovered value? Let's say this 3. Let's say this 3 is the smallest uncovered value. Any 3 you can take, right? This 3 or this 3 or this 3, any 3. So all the 3s are same. So all the 3 will be treated as a smallest value. So this is the smallest value, right? So what I have to do? I have to subtract this smallest value from uncovered value. So I have to subtract. Okay. So let me subtract this. Okay. So should I use some different color? Okay, fine. Let me use this color only. So 3 minus 3 5 minus 3, and this is 7 minus 3, and this is 3 minus 3. So these two are now covered. So this is no need. Now 3 minus 3 minus 3. Okay, so this much values are only required. So I am writing it here. So it is 0, 5 minus 3, 2, 7 minus 3, 4, 3 minus 3, 0. So this mid 0 I have not touched. Why? Because it is covered. And I am reducing 3, I am subtracting 3 only out of uncovered values. So that's why. So this is the reason. So this is 10 minus 3. So it is 7 now. And this 3 minus 3, it becomes 0. And 5 minus 3, it becomes 2. It becomes 7. And this last column is cut. So there is no other value left, which is uncovered, and 3 is not subtracted. So all the uncovered values are subtracted from smallest uncovered number. So smallest uncovered number is 3 in our case, right? Now what I have to do? I have to add this 3 in intersection value. So where is intersection value? Let me see. Okay, so where is intersection? This is intersection, right? This is intersection. And second intersection, this is the second intersection. So here I will add 3. So if I add 3, so 1 plus 3, it becomes 4. And 3 plus 3, it becomes 6. Remaining all the values, I have to just copy it. Remaining all the values, I have to just copy it, right? In the next table. I have not to do anything for these remaining values, right? So let's write remaining values. Okay, from some different color. Okay, let me check. Let me try this color. Okay. So remaining values are, where are the remaining values? Yes. Yeah, this uncovered, this covered value, which are where I have not to make any change. So I have already told you that where you have not to make any change, you have not to make any change in uncovered in covered values. So it is written here. So where I have not to make any change, I have not to make any change in case of covered value. Where I have to add smallest value, I have to add smallest value in case of intersection value. And where I have to subtract smallest value in case of uncovered values, right? So I have already reduced or subtracted smallest value out of uncovered value, and I have already added smallest uncovered value in intersection value, right? So in our case, which is our smallest uncovered value, that is 3. So rest of the values I have not to change. So that is copy, right? So 0, and this is again 0. This is 3, and this is 0, 0. These are uncovered. These are covered value which are not lying at any intersection, right? 3, 8, and this is the last one. This is 0, and the last is last row. Yeah. One more thing we missed out. We missed out because this 0 is again at intersection. Which 0? This 0. Let me show you again. This 0 is also at intersection. So here again I have to add some value, that smallest value. So that our smallest value is 3. So this will be 3 here again, right? So now go back to some different colors. Okay, fine. So 2, 4, 2, 0. Now you can see the values which are written in brown color. Those values are the values which are falling at intersection in previous table, right? You can see, right? And the values which are written in a green color, these are the values which are uncovered in previous table, right? And the values which are written in violet color, I think, and these values are covered value, but not at intersection. So you can discriminate it properly, right? Now again, the same job I have to do. I have to do assignment. So that is the only thing which we are doing today, right? So in the first row, there are 2 zeros, escape. No need to do anything. Second row, there are 2 zeros, escape. Third row, there are 2 zeros, escape. Fourth row, there are, okay, no, there is, because there is a single zero. Yes, single zero. So once I assign this zero and I cut this zero, right? I cut this column of job 2, right? Now, so now come to the, after this, come to the row 5. Is there any single zero? No single zero. There are 2 zeros. Now come to column wise. Okay, come to column wise. Is there any single zero in this column? No. Skip. Is this is already deleted, right? Is there any single zero? Yes, this is a single zero. So cut this row. Is there any single zero? Yes. Earlier there was no single zero. There were 2 zeros, but now 1 zero is cut. So second zero can be assigned, and you can cut this row as well, right? Now come to this. Is there any single zero? Yes, there is a single zero. So assign this 0. So I have done row wise and column wise. I found there is still 1 zero which is unmarked. So that is one job and one person. So I will mark it. Again, I will do row wise, and there will be the single zero. And now I will cut this column. So what I have done? I have done first assigned row wise. Then I assigned column wise. After that, I found there is 1 zero left. 1 0 left, which is not in the square or rectangle, what we say, and which is also not cut. So again, I have done row wise, and I checked that, okay, I have marked that 0 and cut that line. Now how many assignments are there now? How many assignments are there? If you find how many assignments? Okay, so let me check how many assignments. This is the assignment number 1. This is assignment number 2. This is assignment number 3. This is assignment number 4. This is assignment number 5. So number of assignments. Number of assignments. How many assignments? Assignments. That is 5. And number of rows. That is also 5. Now it is a optimal solution. Optimal. Why optimal? Because number of assignments are equals to number of row. So number of assignment is 5. Number of rows are also 5. Number of assignments are 5. Number of rows are 5. Both are same. Both are equal. So, or in other way, we can see how many lines? 3 horizontal lines and 2 vertical lines. You can check it out. 3 horizontal lines and 2 vertical lines. These are 2 vertical lines, and 1, 2, 3. These are 3 horizontal lines. So total lines are 5. So total lines are 5. It technically means there are 5 assignments, and 5 assignments. And if we have 5 rows, then we need only 5 assignments. Why? Because at a time only one person will do only one job. So which job P1 will do? P1 will do job number 1. P1 will do job number 1, and P2 will do job number 3. Job 3. P2 will do job number 3. P3. See P3, and P3 will do job number 4. P3 will do job number 4. P4 will do job number 2. P4 will do job number 2. P5 will do job number 5. Job number 5. Okay, how much time? Now From where we will get this time? We will get this time from quotient, what is given in the problem, right? So as we know that P1 will do job 1 and P2 will do job 3. So let's see. Go to question. What is written here? P1 will do job. P1 will do job 1. Right? Okay, let me erase this first. Then you will properly understand. So P1 will do job 1 and P2 will do job 3. So what is that value? 10 and 6. So P1 will do job 1 and P2 will do job 3. Okay, so let me write it here. So P1 will do job 1, so 10 hours. P2 will do job 3, so 6. Okay, value is 6. Let me write it properly. Okay, so value is 6. Now P3 will do job 4 and P4 will do job 2. P3 will do job 4 and P2 will do job. Okay, let me check. So P3 will do job 4. So it becomes 4 and P4 will do job 2. It is 9. Let me cross check it here. P4. Okay. So what is given in our case? In our case, it is given. Okay. P3 will do job 4 and P4 will do job 2. So let me check here. So keep checking and keep checking. P4. Sorry, job 4. So job 4 is 4 and P4 will do job 2. So it's 9. So I'm writing it 4 and 9. 4 and 9. 4 and 9. Now job 5. So P5 will do job 5. So let me see the value from the question again. So why I am doing this exercise? So that you should recall that always we have to see the value from question. So that is job 5. So that is job 5. Check properly. P5 job 5. So time is 10 hours, right? So 10 hours, right? So I am writing it 10 here. So what is now total? Total is 20 and 10 plus 6, 16 plus 4, 20 plus 9, 29 and 10, 39 hours. So what should be the schedule? So P1 should do job 1, P2 should do job 3, P3 should do job 4, P4 should do job 2. Okay, let me write it. P4 should do job 2 and P5 should do job 5. If we follow this pattern, then we will get minimum time of 39 hours. I hope that my point would be clear now and you understood the concept. So we are stopping it here. So in the next session, we will discuss some other topic related to operations research. Thank you. Thank you, friends.